Welcome to our Authorization Security course. This is the third course in the Common Security Flaws training series. I am Josh Bressers, a member of the Red Hat Product Security team. This course will help you better understand some common issues associated with handling authorization. Before we get started, let's do a brief review of some definitions. Flaws are program errors or bugs. Security flaws are bugs with potential security impact. Vulnerabilities are security flaws that are exploitable by attackers. Vulnerabilities are caused by security flaws, but not all security flaws result in a vulnerability. This course will focus on authorization flaws. First, we will provide an explanation of authorization and how it differs from authentication. Then we will investigate failures in checking authorization and conclude with a discussion of cross-site request forgery or CSRF flaws. So what is authorization, and what exactly do authorization flaws entail? The concepts of authentication and authorization are often confused. Authentication is the identification of a user, usually based on some identity characteristics or shared secret, such as a password. Authorization is the association of privileges with users and validation that a user has the proper access level to perform certain actions. For example, we might think of an administrator as a user role. Each time a user tries to perform an administrative function, the authorization check validates that the user has admin privileges. In security, both authorization and authentication are important. However, we will focus on authorization, which is the more overlooked and complex of the two. With any privileged or sensitive action, there must be an authorization check. Sometimes these checks are based on the user or user role. For example, only admin users can restart the web service, or only root users can install new programs. Developers may overlook some of these checks, especially for certain edge cases in non-traditional access methods. Attackers can leverage such oversight to gain access or perform privileged actions. Unlike many other security flaws, most authorization flaws are flaws in the program design more than its implementation. Here's one example of a poorly designed authorization system. The intention is to have each car stop at the gate and for the driver to authenticate themselves to the system. If the driver is then authorized, the gate will lift and the car can pass through. However, it's often easier to bypass the access control altogether by just driving around it. Further examples of poor authorization design include setting an externally accessible variable or cookie, such as an isAdmin variable, in order to check for administrator authorization, validating initial access to a resource and not verifying authorization to related resources. For example, authorizing access to a URL for a bank account, but not revalidating if the attempts to access a different account by modifying the URL parameter. Protecting the primary access mechanism, but overlook secondary access methods. For example, access to a configuration file may be correctly checked and authorized via the program interface, but the user may be able to use another method to overwrite the file contents, such as by uploading a new version. The best way to mitigate authorization bypass attempts is to place the authorization checks as close to the access point as possible and to ensure that there are no backdoors. Always revalidate authorization for each attempt. Additionally, developers should use only approved authorization methods and libraries. Some authorization methods, while seemingly good, have certain flaws, such as not properly clearing caches or tying privileges to externally controllable values, such as web cookies or hidden files. The final authorization flaw we will discuss is cross-site request forgery, or CSRF. This type of flaw leverages concepts from cross-site scripting. If you've not recently done so, I suggest reviewing the Common Flaws training course on cross-site scripting before continuing. CSRF stands for cross-site request forgery. It's easiest to explain a cross-site request forgery flaw as a design flaw that is a hybrid of cross-site scripting and authorization flaws, whereby an attacker can use the user's web browser to send a request on the user's behalf. These requests are not spoofed, they're legitimate requests from the browser, but are made without the user's consent or knowledge. A typical CSRF attack occurs when an attacker gets a user to navigate to a malicious website. While the site loads, background automated functions, such as the page onload event or using JavaScript, sends a request to another URL. Since this request is sent from the user's browser, it has access to other active user browsing sessions and cookies. The attacker can use this to issue requests or authorize approvals for monetary transfers, trades, or issuing a like or +1 or friend request for certain people or items. When authorizing certain actions, we need to verify that the action was actually initiated by the user. The standard way to approach this is with an "Are you sure?" response to the request. This response must also include a randomized challenge token to protect against the attacker from hijacking this approval as well. For the action to be approved by the user, they have to both verify that they want to authorize the action and must provide back the correct randomized challenge token. For more information, the OWASP CSRF Prevention Cheat Sheet is a great resource on how to mitigate against CSRF flaws. This concludes the authorization course. We encourage you to try the other common security flaws training courses. Thanks for listening.